Hi, everyone, and welcome to today's Rancher Online Meetup. I am Shannon Williams, and I'm excited to have all of you here with us today to talk about Rancher 2.4. We're going to be diving into the latest release of the Rancher product and talking about all sorts of things from security to operations to scaling, and it should be a lot of fun. I'd like to start by just introducing the cast here on the meetup today. Again, I'm Shannon. I'm one of the founders here at Rancher and responsible for a lot of the work we do out in the world. Darren Shepard is joining me. Darren and I have been hosting this podcast for a long time, or this meetup for a long time. Darren, you want to say hello?
Hello, everyone.
Darren is going to be coming up at the end of the session, demoing some cool new stuff in Rancher. Bill Maxwell is also joining. Bill is the lead of our product management group here at Rancher. Bill, you want to say hi?
Hey, everyone.
And finally, Denise Shannon is joining. She will be talking about security and some of the new security features. She's the director of engineering out in our Cupertino office. Hi, Denise.
Hi, Shannon.
How you doing this morning?
I'm doing good. How about you?
I'm feeling quite chippy, actually, and excited to get back to doing one of these. I haven't done an online meetup in a couple of months, so I'm excited to be doing it, and really excited for this discussion today because it's a topic that I know a lot of people are really interested in. They're interested in learning more about the new release, and we're excited to dive into the details and, as always, get into the meat of it. So I'll start us off as we always have. Just kind of remember, this is meant to be a meetup, not a webinar. It is your chance to talk, chat, ask questions, stop us, go into details. There is this is an idea we had, back when we did our very first webinars back now almost 5 years ago. Our first meetups, we started talking about, kind of getting people together, spending a couple hours, diving into the technology and bringing people from around the world. You can see how old this is. It was Docker Compose is what we were talking about at one of the very first ones. But it's been an awesome experience, and what's made it great is all of you. We get, I know there's many of you who've been attending these since those very earliest days of Rancher and this open source community built up around Kubernetes and Docker over the last 5 years. So a huge thank you to everyone who's been coming. A huge thank you to Darren for being on so many of these, Bill being on so many of these. It's been a ton of fun. So as always, these are the kind of concepts we apply to our meetup. We don't set a time limit. We cover a lot. We've never done it in an hour, so please don't be concerned that we seem to be moving slower than some of these things you might see. We do record everything, so if you have to leave, don't stress about it. We really spend a lot of time answering questions. If you've ever attended, the question button and go to webinar has been our lifesaver. Fire away, send whatever you've got. There's no bad questions. We do focus a lot on demoing, so you'll see demos today from everyone. We're not gonna, we have slides. We sort of lay out the concepts in slides, but we like to show, so things break sometimes. Be patient, and we'll try to get things moving. As I mentioned, this is being recorded, as have all of these meetups, so you're welcome to go back and watch later, watch any of these that have happened in the past. Like I said, I think you can find a channel that goes all the way back to our 2015 meetups. So don't worry if you do have to step away. We do have this all recorded. The other great thing is we use Twitter to meet each other. We have a Twitter hashtag Rancher Meetup that's been around for a long time. When people join, I always encourage them to post a picture, say hello, introduce yourself to the rest of the community, throw a hashtag on there. I'll certainly reach out afterwards and give you a follow and say hello as well. So please don't just kind of participate quietly. Introduce yourself. The other way we connect is on Slack. We have slack.rancher.io. It's a general purpose Slack that we talk about all the time, and we talk about, it's a place to get all sorts of help with Rancher's projects. But we also have a channel called Online Meetup in there if you want to join and discuss things that, for whatever reason you don't want to talk about in the question side here. It's a little more interactive. Please join. Okay, so our agenda, I'm going to provide just a quick update on Rancher, a little bit about the company for anyone who doesn't know who we are, any of our first timers. Then we'll be diving right into this 2.4 release. Denise will talk about the security enhancements, some of the work we've been doing on CIS Benchmark, OPA in 2.4. Bill will talk about operations and zero downtime upgrades, some of the work we've done to incorporate K3S in some cool ways into this new release. Then Darren will introduce a new project he's working on called Fleet, which is going to be an important part of Rancher in the long run. So we'll talk about that. That's all about scaling up cluster management. And then if your questions haven't been answered by that point, if there's still questions, like I said, we're not going anywhere. We'll stick around and answer them as we go. So big agenda, lots to cover. Fire away with your questions. We'll do our best to answer them all in the tab or ask them out loud if they seem like something that a lot of people would want to discuss in more depth. So for those of you who aren't familiar with Rancher, Rancher is a software company. We've been growing a lot since those first meetups back in 2015. We now have literally offices all over the world. We work with tens of thousands of organizations to help them implement and manage Kubernetes. And at the heart, we've been really solving the same problem since we started the company, and that is, helping organizations build their next generation of computing platform. The idea has really remained quite consistent. We really believe that infrastructure is getting more and more distributed, and whether you're in the data center or the cloud or you're out in the edge or running this on your laptop or connecting to branches, that Kubernetes is a fantastic, equalizing technology. It allows us to run a common set of capabilities anywhere. It's easy to implement. It's getting easier, and it really provides a ton of value beyond simply what you can do with Linux or with Docker, especially around being able to programmatically design how you want applications to run, not just to deploy things. The challenge that people run into is this sort of middle blue layer of centralized management. We find that as organizations scale, Kubernetes tends to pockmark their whole organization. Clusters appear anywhere and everywhere, and so for many organizations, the challenge becomes how to operate all those, how to make sure they are secured, how to ensure that you actually have a highly reliable layer of technology at that distribution level, and then to provide the ecosystem around them. It's the great thing about our space is how much it has continued to kind of foster innovation. We see new tools and technologies continually emerging and then becoming slowly standard. And so one of the things that we find is for a lot of organizations that means a lot of work building and trying to integrate all of this. We try to do that in a standard way that anyone can access and get connected to some of the cooler technology around this. Finally, once you get this up and running, there's a lot to do on top of the platform to build applications. And so over time we have continued to work and innovate and try to help organizations figure out what to do there. And if you look at the stack of technology we've built, at Rancher, we deliver certified Kubernetes distributions that are easy to deploy and easy to use. RKE is our kind of normal traditional upstream distro. It's used in the data center predominantly. K3S is our lightweight edge-oriented distro. It's used for laptops. It's used for kind of deployment on single or multi-node out at the edge. We also see tons of adoption of cloud-hosted Kubernetes from Amazon, Azure, Google, and other cloud providers around the world. All of these are great. They all are certified distros. There's a lot more. The number of distros out there, the number of ways to build Kubernetes is not lower, coming down. And so while we provide some of these, and we certainly work really closely with the cloud providers, what Rancher itself does is the management layer. It implements all of the operations and infrastructure management to make it easy to provision, operate, and manage these types of clusters, to incorporate them into a common platform, and then to deliver standardized security, user management, policy management, so that as an org you adopt these technologies and they all work together. On top of that, then we have to really spend a lot of work taking the the user experience and building UI, building dashboards. We're going to show you some new dashboards, in fact, today that make it easier for teams to work either as operators of this platform or as users of this platform. And that also includes bringing in a lot of new technology. You can see some of them up here: Istio and Envoy, Fluentd, and Prometheus. But we're kind of, that group is constantly expanding. We added OPA in the newest release of Rancher, and we're going to be talking about that today. We also have a really cool project called Rio that's still in beta, which really focuses on how to implement some of the more PaaS-like functionality on top of Kubernetes as your teams are kind of onboarding more and more applications, and you want to do, build from code, do more canary type deployments, do auto scaling based on sessions, kind of automate even more of the work. Rio is a Kubernetes native PaaS that's easy to use, easy to deploy, and provides a lot of usability for teams that are trying to ramp up the adoption of Kubernetes to more and more teams. So we work at all these levels. I'm not even touching on some of the other projects like Longhorn and other things that we do, but there's a lot going on, and all of it is open source. So at Rancher, we're big members of the CNCF. We've contributed projects to the CNCF. I'm on the governing board of the CNCF, and we're huge believers that this revolution is going to be open source. And so we make our products available open source. The huge majority, 99% of people who use Rancher use the open source versions. In fact, everyone uses the open source versions, but about 1% to 2% are our clients who work with us and take support from Rancher on this whole stack to make it enterprise grade for their organization. So that's who we are. That's our business. It's been an amazing run. As somebody who's been a part of a lot of startups, this is certainly the most exciting space I've ever been a part of in terms of the amount of innovation and the impact of that innovation. So thank you all for your support, for everyone using Rancher, and it's been with us on this journey from the earliest days to now. It's been awesome. So today we're going to get hands-on with Rancher 2.4. There's a load in this release, tons of new things. I'm just going to highlight a few of this, kind of high level over the release, kind of touch on our process. We release, major releases like this every 6 months at Rancher. So this is our 2.4, 2.3 came last fall, 2.5 will come this upcoming fall. And, we tend to make a lot of technology available in each release. Most of it is kind of GA. Sometimes we release features under preview because there's still, maybe some of the stuff they're based on is still kind of an early development, but we want people to get hands-on with the products as soon as possible. So there are really kind of three big buckets of work we did on this. The first is the security and authentication area. We did a lot of work to introduce CIS benchmark scanning in 2.4 to allow you to track all the clusters you're running and make sure they meet compliance requirements around security. Denise is going to talk quite a bit about that. We did a lot of improvements to the auth engine in 2.4, added support for a bunch of new types of authentication, shibboleth, a number of sort of cloud-hosted approaches. We also added the ability to do more editing of the custom global roles and assign roles to groups. And so there's a lot of cool improvements on the security side. One of the ones I'm most excited about is the introduction of OPA. This is a project we've been participating in for a while and excited about. We are rolling out this, this with 2.4 as a preview, and Denise will talk a lot more about that. On the operation side, and that sort of helping to, to manage clusters more efficiently, this has been a big focus of Rancher in the previous 2.3 release. It's a big focus in 2.4, and it will continue to be a big focus in 2.5. There are a lot of things changing. Big one is just the industry is moving from a vision of Kubernetes as something you manage as one big cluster to something that is being deployed in lots and lots of clusters and lots of places. And so we're introducing more and more scale. Today the biggest Rancher clusters out there running hundreds of clusters, a couple hundred Kubernetes clusters is a large, significant cluster scale for people on 2.3. With 2.4, we go up by 10x on that to support up to 2,000 clusters and over 100,000 nodes. That's a big jump in terms of what people are using it for, but we see projects coming down where people are planning to do all sorts of amazing things at endpoints, and so we're excited to scale up the amount of cluster management. And this is a lot of what Darren and Bill are going to talk about in their sessions. The other big thing we did was kind of rethink how to do cluster upgrades and do it in a way that has no downtime, doesn't require you to to have any impact on the applications. This is a really exciting piece of work I think Bill will be talking about in quite a bit in his session. We're also going to talk a little bit about the sort of limited connectivity maintenance. This is something we're getting requests for as people begin to use K3S as embedded systems, on devices that are out, security cameras or oil wells or vehicles, or just all sorts of different things where the ability to connect is not consistent. So how to maintain upgrades, how to kind of check for upgrades when they come back online, how to check for new software pulls. So we'll talk maybe briefly about that. I think Darren may touch that a little bit because it's a lot of what he's been working on. There's a whole bunch more in this release, probably stuff we won't get into. One thing you will see a bit is sort of a whole bunch of new UI features that will be here, a new dashboard. This is something we've been, we're going to be rolling out sort of over the next couple releases. So you'll start to see new capabilities appearing in, in new dashboard that we're really excited about. It allows for really detailed viewing of Kubernetes resources and getting into, kind of more complex management. I think as the number of clusters and the scale of those clusters are expanding, we keep looking for ways to make the UI more intuitive and the experience a lot stronger for people that are managing these things. We did some changes to how you install Rancher, allowing more backend support. In the past, we'd only used etcd. Now we can run Rancher with MySQL as a backend, which has a lot of interesting things, especially for running it as a service or delivering it, in the cloud, where you can just easily grab RDS or some other kind of hosted SQL service. There's a whole bunch of improvements on OS supports, just as we kind of roll out new OS support, and we upgraded Helm to Helm 3, so we can now use Helm 3 catalogs. So with that, we've covered a ton. I want to hand it over to Denise, and she can dive right into all the security improvements in 2.4. So Denise, let me make you the presenter.
Okay.
And you can head out.
Okay, let's see. Perfect. I think everyone should be able to see my screen.
I can certainly see it.
Okay, let's get started. Okay, so as we mentioned, in 2.4, we added a bunch of features to help you secure your Kubernetes cluster. As everyone knows, like Kubernetes is not only challenging to usually configure itself, but to configure it securely, there are a lot of options, and it's usually daunting to figure it out. So CIS has already created a set of benchmarks of when you configure Kubernetes, if you set these configurations on, then your cluster will be secure. And usually you have to manually run these benchmarks against your clusters. So in 2.4, what we've done is introduce the ability so that you can actually automate running these benchmarks across your clusters. So we refer to them in Rancher as CIS scans. So you can scan them against any Rancher launched Kubernetes clusters, or otherwise known as RKE clusters, for the vulnerabilities. After you run it, you'll be able to download the report that shows all the tests that were run, whether they were passed or skipped, or if they're failures, and you can use these reports and share them with your auditors. And then once you basically configured and you have your CIS scans configured to be passing how you want it to be, the next step is usually you'll want to schedule these scans so that as time goes on, if any changes are made to your cluster, you want to make sure you're still within compliance. And then say someone does make a change and it starts to fail, you could use the alerts that are within Rancher to send you an alert to the fact that your scans are starting to fail, so something has changed in your cluster to do it. So then after you've set up your cluster itself to be secure, the next part that usually is hard to control is how do you control your users on what they're deploying, because basically anyone who has access to the cluster can really has the ability to deploy anything. And so usually a lot of companies have security practices or policies that they want to try and enforce on their users. the example I'm going to use in demo today is, what if I have one specific image repository or like organization that I want everyone to deploy from. So how do I control it so that no one is actually using that outside repository from somewhere else? So what we've done is we've actually integrated with OPA Gatekeeper, which allows you to start being able to create, these policies and enforce them within your clusters. So one of the things is Gatekeeper in Rancher is experimental, otherwise known as like previews. And the reason that is because Gatekeeper itself is currently in beta. So I think there are plans for it to GA sometime in 2020, but we're keeping a close eye on it, where as they roll out newer beta releases, we're going to try and incorporate it and try and get the latest and greatest into Rancher. And so with Gatekeeper, what you can do, there's two concepts in there. So there's a template and a constraint. So generally you create a template, which allows you to configure like a high level policy. So for example, the template that I'll show you today is going to be the fact that you want to limit which image repository or resources are coming from. So that's like the template itself. And then what you do is we create a constraint based on that template. So in my example, I would then say I want this namespace with any pod in this namespace to actually be deployed from my specific image repository. And that is the constraint itself, where it talks about which namespace, which resources, and what repository it would be applicable to. And after you create the constraint, you can actually start to view any existing violations, on your resources. So I have an example today where I've already deployed stuff that's broken. I've created a constraint, and we'll be able to see what the violations look like. And then afterwards, you'll be able to it actually prevents users from continuing to, violate that constraint. So after you've cleaned it up, you can now be like assured that essentially your users cannot continue violating the constraint that you have. So a couple of Gatekeeper examples that I have up here. So Gatekeeper itself has a lot of templates already listed. The templates, I will admit, they're a little tricky to set up. And so they've already created a bunch of templates that are really useful. So, the one example we're going to go through is like allowed repository. So being able to select, which image you want for being able to deploy pods. And it doesn't have to actually be only pods. I think it can apply to, other resources. You could set container limits. You can set up a template to like require labels on, the resources you're creating. And then they actually have like a whole set of templates that mimic pod security policies. And so usually what happens is like the next, I guess, intuitive question is like, well, what happens to PSPs or pod security policies? So, PSPs continue to exist, but it's really constrained to specifically how are we going to deploy the pod itself. And so Gatekeeper is kind of like, I view it as like one step above, where you can not only restrict what is going on in the individual pods, but you could put in more constraints across like your cluster, your whole cluster itself. So Gatekeeper has already done this great job of taking like the most common PSPs that are out there. They've already created templates for it. It's part of that library that I showed you. And then, in the README, this is where this little chart comes from in terms of what you normally would want to control and how it works on PSPs. And then what is the template, and then an example constraint that you can use as well. So that's the end of my slides before I go to the demo. I guess, Shannon, is there anything before I get to the demo? Are there any questions?
Sorry, I was on mute sitting here talking. Yeah, there's a couple questions. One of the questions came from Christian. He said, I'm new to OPA Gatekeeper. Is it possible to do execution prevention with it, similar to something like SE Linux?
Yeah, I think so. I think when I remember looking at the PSP like conversions, there was one that said, something around SE Linux. I didn't look into the template itself, but I believe that Gatekeeper has something around that.
So this is Darren. So OPA largely focuses on kind of what's the definition of your resources and ensuring that like the definition of the resources are secure. So you can use it basically to manage SE Linux configuration and whatnot, but like on the runtime aspect of the actual container, like the processes running, that's kind of outside the scope of OPA. So just want to make that clear distinction. So OPA is largely, it's like as you're modifying resources in Kubernetes, it's looking at the definition of those objects and making sure that they're matching a policy. So it's not actually inspecting the running processes or the running containers.
There was another question that came in, Denise, about the CIS benchmark scanning, asking if we're using Kubench under the covers, and I'll let you talk about that.
That's a great question. I mean, we have our own scanning tool. I actually don't, I'm gonna admit, I don't know what the specifics are of it.
I can do that one. Yeah, we are using Kubench as the engine, but at this time it's pretty hidden from the user. We haven't opened that up, so it's not a generic Kubench, but we definitely leverage the tool and are looking at different ways to expand that in future releases.
There's another question. Do the CIS scans require internet connectivity, or can it be run with an air-gapped environment?
It does require internet activity. So I can show, I mean, I could demo the CIS scans unless you want to keep going through the questions.
Why don't you keep going and I'll answer them.
I mean, I think that's a good transition in terms of the demo. So what happens is, so I've already created up a cluster, and then under the cluster, under tools, you can go to CIS scans. And all I did for the meetup today was I had, you know, set up a cluster. I just used the RK defaults that were out there, and I ran the scan last night just so that you guys could see it. But in terms of running a scan, what you do is, you know, you can click on run scan. You can select basically a profile. So we have two profiles, and there's one that's called permissive and one that's hardened. So what the differences are is the permissive basically is a scan that will automatically skip. You can see here that there are about 15 skip tests, where based on the defaults that we have for our RKE clusters, you have to skip these tests in order for it to pass. And the reason why they aren't selected as a default is because, you know, by enabling it, it could cause performance issues, or enabling it you might unintentionally like configured something that you didn't realize you were turning on that might restrict you. For example, like you could turn on like PSPs, and then, you know, stuff might actually not be configured correctly, and you might not be able to deploy and not understand why. And so what we have is the permissive one, which follows along with what the RK defaults are. And then you have the hardened one, which doesn't skip any tests. And in order to get that passed, usually we recommend users to follow the Rancher hardening guide, which is up on our doc site, to be able to harden your cluster. And then once you have a cluster like that, you'll be able to run the scan. It won't skip any tests specifically, and then it will pass itself. So besides the tests that we naturally skip, I guess to call it, there's also these tests that we do skip, but we skip them because they're not applicable. So based on the fact that like RKE is configured, the way RKE is set up in terms of how we configure and launch Kubernetes, there are a couple tests that are just not applicable to our type of cluster. And so, you know, we've outlined, you know, reasons of why it doesn't do that. So anyway, so it's pretty easy. You just go, you click on which profile you want to do, you click on run, and then this is where I guess you require internet, because what happens is the scan tool is actually a Helm chart. And so what it does is it deploys the Helm chart and basically starts running the scan against the cluster, and then it creates a report, and then the workloads that are generated through the Helm chart are then stopped, and then the report comes out. So then after you get your report, you can click on it, and you can see that there is, you know, a list of skip tests. There's a list of all the tests that we pass, and then at the bottom there's which tests were part of the like not applicable section. From here, you can download your report. It becomes the report itself is just a CSV file, which dictates what test numbers there were, the description, what nodes they were run on, and whether or not they were passed or skipped. So usually after, sorry, someone on our end isn't muted, but I don't know who. So usually after you start scanning it, it's all passing. What we want to do is actually start to schedule our scans so that we know that it will continue to be compliant. So here I can click on the add schedule button. What you're doing is you're editing your cluster itself. In this section, I can click yes, I want to start scanning at a scheduled rate. You can pick which profile you want, as well as how often you want to scan, and then how many to keep. I can then click on save, and essentially we'll start scanning at that interval. The next part is usually after you start scheduling the scans, is like obviously we'd want to know if suddenly your scans started to fail. So scheduling is the first part, and the next part is alerting. So in Rancher, we already have the ability to set up alerts, and so all we've done is now created an alert that's specific to the CIS scans, where you can have alerts of anytime a scan has been completed, and then you could actually set up, and this is the one where I think is the most important, is like if you start to have failures within your scan itself. So I could set up, my scaling. Oh, I forgot I haven't set up a notifier, but basically you could set up your alert, and then usually what you do is before you create any alerts, or you can create an alert, but what you need to do is actually select a notifier. So like who you want or how you want to be notified that something is failing, or of your alert itself. And then you could create, and then now it would be set up so that if there was a failure of my scan, I would be able to get notified about it. Now, that's about my demo for CIS scans. I want to take a break before I jump over to Gatekeeper in case there are any questions specifically of what I've just demoed.
There was one question. Hassan asked if we could point the CIS scan functionality to a specific cluster or app.
So each scan is, when you turn it on, it's per cluster basis. So, I'm in my Meetup cluster that I created yesterday, and then I'm in that cluster to be able to turn it on. This is our demo environment, and so I could go to this EC2 cluster. I could go to our CIS scans, and I could, run the scan and start adding scheduling for this cluster itself. So each scanning is cluster specific. Hopefully that answers that question.
It does. There's a question about scanning on the hosted providers, and asking, what you would, if there were any use cases that Eric's asked, like, for example, there's certain CIS benchmarks that test the worker nodes. Is that what you'd be using it more for, or is it configuration? Anything you kind of can talk to about on using this on EKS or AKS?
So right now it's not extended to those providers, but that's something that we're investigating of doing in the future. It gets a little trickier with the hosted providers because the scans itself covered not only of like the control plane and etcd nodes, but it also does the worker nodes. And when you're deploying into EKS, for example, you don't really necessarily have as much control of what you can and can't configure, so that it gets a little trickier in terms of scanning it. So we are looking into what kind of scanning we'd want to do in the future for these hosted providers and what makes sense. And maybe it is that you scan just for the worker nodes, because that's something that we have a little bit more control over. But in general, it gets a little trickier.
There's another question. How do you run the scans when working behind a corporate proxy? Is there any recommendations for using this in that kind of setup? Joan asked that.
Yep, I think actually now that I think about it, like because you're just downloading the Helm chart, as long as you've set up, and I believe it should be where you can set up your, usually in an air gap, what we do is you users to set up a private registry where you have access to, and you could, have access to all those images. So I believe that actually, now thinking through the use cases, that as long as you set up that correctly, it should be able to scan just fine.
Great. And then there was I think, so there was a question from Michelle, and maybe you already answered this. Could the Helm chart for the CIS scan be manually downloaded to an offline environment?
Yep. So our air gap is set up so that. Okay, well, let's go back a little bit. So that Helm chart is part of what we call our system charts repo. So those are any Helm chart that we use for, usually it's most of our tools itself on the cluster. So our monitoring, our logging, Istio, the scans. So the way you set up air gap for Rancher is there's a way that you can configure it to say like bundle in the Helm charts during my install. So you don't have to like have access to that GitHub repo or that repository that has the Helm charts. So that's what you would do is for AirGap, you set up Rancher to bundle in these system charts. So, and then you set up your private registry to have the images. And then basically you've already downloaded in your, like I put downloads in quotes, but you've like have access to that within your internal network itself.
Okay. There was a couple of people who asked, Damia asked, will the CIS scanning functionality be available in the Rancher 2 Terraform provider anytime soon? Balaz also asked that.
Yes, it's, well, you can set up to run an ad hoc scan didn't make a lot of sense, but you can set up scheduled scans when you're, as part of your cluster config. I don't know if you showed that, Denise, but you can schedule the scans as part of the cluster level scanning, and those parameters are part of the cluster configuration, and so you can set those through the Terraform provider. Yeah.
So what Bill's, I can talk a little bit and show it. So what Bill's talking about is like from the scan tool, when I clicked on schedule scans, all it did is actually jump into your cluster configuration. And so whether or not your scans are enabled is actually just part of the cluster configuration. So you could, when you're creating the cluster, you could automatically have it set up to start scanning immediately as well. So I think what Bill's saying is when you configure it through Terraform, you could just have that feature enabled already.
Mm-hmm. Yeah, exactly. And then also these can be made a part of your cluster template, since it's part of the RKE config. So if you're using cluster templates and you want to make sure all of your clusters that are deployed through those templates are, observing their configuration over time, you can have this enabled and alert if something falls out of compliance.
Oh my goodness, there's probably 20, 30, 40 questions in here. Half of them are about CIS scanning, some aren't. One question that I thought was interesting was one that came from Karsten, and he said, are there any plans to incorporate a static image scanning tool like Claire into Rancher so you can scan images? Bill, you want to chat about that? I know it's something we've kind of been chatting about, but it hasn't yet made it to the product.
Yeah, it's something we look at and observe, and constantly ask ourselves if it makes sense to bring that on board. And a lot of times what we find is most customers they end up going down the path of bringing in like an Aqua or a twist lock or running Claire themselves, just as part of a broader security suite. So it's been sort of on the cusp of something we think we'll do and not do. It's really where it keeps coming down to is, and again, there's nothing that Rancher's doing that would actively prevent or needs to do anything custom in order for those tools to work on the platform. And it's something we're constantly watching and looking to see what makes sense.
All right, Christian just said, are there any plans to have scan templates? And I thought that was already in there, but maybe you didn't cover it, didn't you?
I'm not really sure, I'll be honest. What I saw that question, I'm looking at the questions now. I was like, what does that mean to scan templates? Like, I guess what template are we trying to scan? Would be my question. So I'd like to
modify maybe the parameters of the scan. So like only scan X, Y, and Z or something like that.
That is customizable. Today, the CIS scan is working primarily on RKE clusters, but if there's a configuration that you've knowingly adjusted, or is there a control that you're willing to relax, you can have there's a config map you can edit that allows you to skip certain tests as part of your as part of the profile. And so you can customize it within the current working constructs. There's a couple different paths we can approach going forward as we add support for other, as we add support for EKS, AKS, and the hosted providers and other types of arbitrary types of clusters. I think that's where going out on a limb, just thinking that it's probably what the user means is, or the question is that it's tied to the Kubernetes profiles, which are fairly flexible and just Kubench is a test runner and it takes in a profile of tests to run. And so, whether we open that up to allow kind of custom configurations. So if you're running on like with another Kubernetes tool, provisioning tool for like an imported cluster or something along those lines, we're still investigating and trying to figure out what the best path forward would be.
Awesome. Why don't we keep moving?
Yep.
Denise, we'll keep answering questions on Slack or on question.
Yeah, I can also come back to, once I'm done my part, I'll go back and answer the CIS ones as well. So, okay, so let's keep going. So now, now I'm going to demo about OPA Gatekeeper. So this is actually held in our dashboard. So if you click on Try Dashboard, I'm just going to open the one I already have. It jumps to our new dashboard view that Shannon touched briefly about. I'm not going to go into great detail about the dashboard itself because I think Darren's going to cover it a little bit more. But here, there's a little OPA Gatekeeper link. I've clicked on it. I've actually already turned it on. So it's enabled. You can see it's running in which beta version it's running. And you can already see that I already have some violations in my setup. So what I have in Rancher today is I have a namespace that has basically 2 images deployed. One comes from Docker Hub and one comes from Quid.io. So when we deploy Gatekeeper, there's a set of templates that are automatically deployed. We picked ones that seemed like some basic use cases that people might want to be able to do. So there's one that's called allowed repos, and there's one that it's called required labels. So the allowed repos template is where you can pick constraints that basically enforce images to come from a specific image repository. And then the required labels one is where you could have your no resources could be deployed unless it has these specific labels. So usually we anticipate most people are going to take the templates from Gatekeeper, at least the templates they have. And then where it comes into the customization is the constraint itself. So I'm going to, let's see, click onto my form itself. So here I have this one that's basically says that, it'll list out what my violations are, and I'll go into which one it is. But essentially, the parameter itself is saying that for the repos that I only want it to come from my org only. So this is someone within Ranchers, their specific org. And then I select which which namespace I want, this constraint to be applied to, and then you can exclude certain ones. So we by default exclude the namespaces that Rancher uses to help deploy and manage your clusters. And then what you do is you can go to kinds and you can select, which resource type that you want it to be applied to. So my use case is real simple. It's I want any pods within my namespace of Ubuntu testing. They must come from this image repo of Quid.io and then this specific person. So you can already see I have a violation where I have this container that is using the Docker Hub repo of Ubuntu, and it's actually violating it. So it's great that in the sense that it shows it. And then I have a second constraint, which is basically the same thing. It just is more generic to say that it's like quit IO. So I'm going to jump back to Rancher so that we can see what we can do to kind of like see what's going on the Rancher side in terms of what you would see. So what happened here is I actually had already set up my workload, so they were already running, and then later I decided that I wanted to put those constraints in, and so that's why there's already an existing violation. So to remove that violation, I would end up, deleting, finding that workload, deleting it, and eventually Gatekeeper will, update and say that there are no more violations. It's usually about a couple minutes before the violations are like synced up. So I'll go ahead and delete that now. And then what I'm going to do is I'm going to actually deploy and try and deploy another one. I want to, use that same image that before was violating. I'm going to try and launch it in there. And then what happens is essentially Gatekeeper denies the request and doesn't let it go through. So it'll deny it and not let the image or the workload to actually be deployed, and it tells you why it can't actually be deployed. And so that is, one of the use cases of, like, I guess a simple use case of, how you could, enforce like whitelisting registries of only wanting these registries in your cluster itself. That is like basically it. I think I can go back to the dashboard and we can kind of view it, and eventually these violations will clear up. But as I said, there is a little bit of a sync between before the violations will finally get cleaned up. Now, I know I went through that. Are there any questions? Because I know this is like a brand new concept out there, so I'm sure there's going to be a lot.
Sorry, I had to unmute myself. Yeah, let's see. One of the questions that Tochukwu asked was, can a remediation workflow be kicked off as part of the OPA Gatekeeper enforcement?
Can you repeat? Can a remediation? Sorry, can you say that question one more time?
Yeah, I said, can a remediation workflow be kicked off as part of the OPA Gatekeeper enforcement is the question.
No. So what it does is it would, once you, I think, well, there's like two ways to view it. I think of it as like, when you actually, deploy your constraint, that's where you can see your violations, and it's up to the user, like myself, to then clean up and, clean up these violations itself. And then, after it's deployed, it basically prevents you from doing it. But, as a user, you'd see immediately that's broken. It's not going to automatically clean up. Like, in Rancher, we tend to be very cautious of ever automatically cleaning up or deleting things, because we want users to know, why something's broken, or actively like deleting and removing it, and not just cleaning it up because, Gatekeeper said it was.
Yeah. And just to expand on Gatekeeper a little bit, it's under the hood, it's a validating webhook. So once you deploy it, all new resources, can be funneled through for like to have policy applied, and then it can reject based on whether, like, so if you're creating a deployment and the policy requires a specific label, and that label doesn't have that deployment doesn't have that label, from the time it's deployed, the policy engine would be able to reject that, and so that would never get created. But there's out of compliances when you've deployed it, applied a policy, and now there's just things in the namespace that have already gotten in there, and so they've gotten past that initial validation step. And so once it's in the namespace, the best we can kind of do for you right now, like the best approach right now, is just to bubble those up so that okay, these are the things that you need to go look at. They don't meet your new policy. And so on the next deployment, or the next update as they come through, you can remediate those.
Okay, another question that came in was from Court, and he said, can Gatekeeper be applied sorry, it's moving around. Can gatekeeper be applied to a cluster or only namespaces?
So it's, I mean, you could select to say like all namespaces to be able to, you know, kind of handle that situation, but it is targeted where you need to basically target what namespaces you want to do. So I think there's ability where you could select it and then you could select all namespaces for it. There is a challenge where I think you could do like star, meaning for all namespaces, but then that will also include, I think you could do that and it'll do all the namespaces and exclude, you know, the set that we have, and then that essentially applies to the whole cluster.
Awesome. Another question came in from Vincent, and he said, can you customize the error messages in the template?
So that depends on so I'm going to assume when you say yes. So I think if you've set up your template in a specific way, you can then have the error messages be displayed when you use the constraint. So in terms of how Gatekeeper deploys, and I can maybe show a little bit, I mean, some other, you can kind of see where if you can set up your template in Gatekeeper. So it's like, I want the error message to be a specific message, and then you can have that show that message whenever it's being violated. It has to usually be set up in the template itself, but it is configurable.
Okay, great. And then I think there was a question here, and I'm trying to catch what he's asking, but you know, with Gatekeeper, is it specific to RKE clusters, or is it specific to a RKE cluster, or can I use Gatekeeper kind of as a cross-cluster, multi-cluster policy that can run across different types of clusters? So there's a couple different questions there, because Cole asked similarly, you know, is there a workflow for a multi-cluster policy? And Gozmet asked about, is Gatekeeper specific for, you know, work for just one cluster? So maybe you can talk a little bit about which clusters are supported.
I believe all clusters are supported, because it's just once again, it's deploying, you know, a Helm chart to be able to launch Gatekeeper. I think it is cluster specific. So you deploy Gatekeeper into your cluster, and then any policies that you set up is specific to that single cluster itself. So there is no concept of having one like multi-cluster Gatekeeper. So we're having one policy across all of my clusters in the setup.
Will it work on imported clusters as well? That was a question Deer asked.
I think so. I don't see any reason not. I mean, Bill, I don't know if we've like specifically tested that, but I don't see any reason why it wouldn't work on imported.
Yeah, as long as you can configure validating webhook on the in your cluster, so that you can deploy and then have the APIs and you know, resources over to the policy agent for evaluation. It should work. It's not tied to RKE specifically, so this should work on the hosted providers and imported clusters, as long as you have the permissions to enable the webhooks and configure the admission controller.
There was another question, and Rich asked, and then Chukwa asked kind of a follow-up to his earlier one. And basically the question is there any form of alerting notification? Can we notify a Slack channel of Gatekeeper violations, or kick off a more complex set of actions, you know, maybe instead of just blocking something? So is it just block, or can it be block and or notify? And if we do notify, can we use any of the existing alerting system in Rancher?
Right now, it's just blocking. There is no configuration to be able to then leverage any type of alerting. But that is an interesting concept that, like, you know, we can look into seeing what could be done. But right now, it just, you know, prevents and blocks.
And if I'm running a lot of clusters, if I want to see all of my policy violations across all these different clusters, can I see that in one place, or do I have to go cluster to cluster to look and see what was violated?
It's going to have to be cluster to cluster. So you can see at least, like, so from this viewpoint, you can see what all your constraints that you have, and it shows, you know, the number of violations. But under the like OPA Gatekeeper main tab, I don't have any more violations because I cleaned it up, but it will basically summarize the list of all the constraints, or sorry, all the violation across all your constraints in your single cluster.
Okay. Well, we've spent we're already an hour into the meetup. Why don't we wrap up our questions here on OPA and on CIS benchmarks? Anything else that you wanted to cover, Denise?
Nope, that was it for me.
All right. Well, thank you very much. Great job, and thanks for showing off a little bit of a preview of the new dashboard UI. With that, let's transfer the presenter over to Bill. Bill, can you do you have control of the ball?
I do.
All right, I can hear you great. So fire away.
Cool. So I'm gonna be talking about zero downtime cluster upgrades and some of the operations. And so I've always liked the analogy of changing the engine on the plane while it's still flying when performing upgrades and updates. It's always been one of my favorites. So here we have our happy cow. So when we looked at this, the key things that one of the key issues is that customers and our users ultimately end up telling us they have SLAs and they have commitments to their users that if you're providing a cluster for development, your Kubernetes API needs to be available for CI/CD deployments as you're continuing to chug through releases, so that you can release software to your end users fast and just move quickly. And the other SLA is typically around your end users consuming applications running on your cluster. So when we were going through and looking at upgrades, we saw that there were a few problems. So in the way that we were doing it initially, so our one of them was that our approach has been to upgrade as quickly as possible and just get things upgraded and back up and running as quick as you can. But there were a couple opportunities where some of those SLAs could have a little bit of a hit. And so it was momentary, but a control plane, we upgraded them as fast as we could all at once. So there was a blip in the Kube API. When we would upgrade all of the worker nodes 50 at a time, that doesn't leave a lot of, while they're done very quickly, it created a situation where your application could momentarily be removed from, or could no longer receive traffic. And then the way that we were doing all of our worker or add-ons, so core DNS, the ingress controller, again, would roll out again very quickly, but still potentially creating an opportunity, a small window where some traffic would not make it to your applications. And so in 2.4, what we've done is we've made several key enhancements. So it's like going from upgrades with your standard hand tools to power tools. That's the way I like to look at it. So now we've given you a lot more flexibility and control and a lot more knobs and dials to tune throughout your upgrade process. So your control plane, you can now select the number of control plane nodes that are being upgraded at a single time. By default now it is just one, so we'll take one out, upgrade it, and then put it back in. So you should be able to rotate those through, as long as you've got them load balanced, you should be able to rotate them through and keep the API available throughout the upgrade process. Worker nodes, where all of your applications are running, are now, you can configure the batch size. So you can do one at a time and roll through very slow. You can now drain and cordon your workloads and move those workloads off of each node as it's going through before bringing it down and upgrading. We've also exposed the Kubernetes add-on upgrade strategies for the add-ons. So now you can select and configure how many of those get upgraded at a single time. And now, just as one other minor little quirk that was in prior to Rancher, once the cluster's API was back up and running, we would inform the user that the cluster had been upgraded, when in fact we were just getting started with the worker node. So now we've adjusted when the feedback for the user, so that you're now notified when the cluster upgrade is actually all the way completed. And we've added a lot of knobs and buttons into the upgrade process, but stuff still happens during an upgrade, and being able to revert quickly we added a new set of functionality around rollback or restore, so that as long as you're taking a snapshot before your upgrade, it's now including the etcd. It's no longer just the etcd database, it's the etcd database, the Kubernetes configuration, and the RKE configuration. So you can revert, Kubernetes version. So you can revert all of that back to the last known point in time. And we do that very, very quickly. And so we're not doing any of the zero downtime stuff. We're moving as quickly as possible to restore that cluster back to that point in time. Yeah. So then the other new feature in Rancher 2.4, and as part of 2.4's story is getting us to the edge and being able to manage fleets of clusters at a time. And so K3s is a key part of that, being able to run a small distribution at the edge and having operational control over those clusters. And there's going to be many, many, many of those. We've added support for upgrading K3's clusters. So you can now kick off an upgrade of Kubernetes versions from Rancher's UI APIs. You can view the configuration of your Kubernetes cluster in a read-only view of both the API and the agent servers. So now this is part of the fleet management, or part of the fleet management and support story that Rancher 2.4 is enabling. And then looking at the scale improvements, again, still tying back into fleet management and where we're going from a capability standpoint. Rancher 2.4, it can handle significantly more clusters and nodes than just even Rancher 2.3. Looking at the small, it used to be able to manage five clusters to now being able to manage 150. So with the same hardware, you can see a better resource consumption, but really, this is pushing up towards where we want to be able to go. So we're now able to get 2,000 clusters and up to 100,000 nodes attached to Rancher. So this is a comparison looking at that. And to do that, we spent a lot of time diving into the code and just looking for things where we needed to optimize. And so one of the big ones we found was that every cluster was getting its own copy of the global context. And so we reduced that so now we changed that so now they share a global context, which has reduced the memory footprint overall. We looked at all of the controllers. So Rancher is performing a lot of operations in the background, keeping things in sync and observing what's going on in the downstream clusters so that we can report and aggregate all that information for you and give you a multi-cluster view of your world. And so looking at some of those controllers and just the logic and what we were doing, we found ways to reduce API calls, reduce the amount of time we're spending looking at just no ops, but still running processes. So we had a lot more, we spent a lot of time diving deep into each of these controllers. So now, if there are any questions while I switch over to a demo.
There were a couple questions, Bill, while you're pulling it up. And one that was asked a couple different times was, is it possible to upgrade RKE imported clusters using this? There's another question, will zero downtime upgrades work for imported RKE nodes and or custom nodes? Do you want to maybe differentiate between imported clusters and or custom nodes, because they're kind of different, and just which clusters are sort of we talking about being able to use this zero downtime upgrade on?
Yeah, so today the zero downtime upgrade is for RKE clusters. These are clusters that Rancher has provisioned directly. So whether it's through custom, node driver, or node driver, those clusters are the ones that we're talking about with this feature. K3's clusters are a special case of imported cluster at this time, and we can upgrade those through a new mechanism, and I'll talk about that. I'll show that a little bit in the demo. And there's last month's meetup goes into depth on how we're doing K3S upgrades with the system upgrade controller. And so I would strongly encourage you to look at that if that's something of interest. Imported RKE clusters are, still treated as a imported cluster where Rancher is unaware of how it was provisioned, and so that still needs to be managed via the RKE command line. But we did add enhancements. The enhancements we added to Rancher for zero downtime upgrade are also a part of the CLI as well. So that should make upgrading your Rancher HA clusters a lot more straight. Be able to take advantage of these enhancements as well. Or if you're provisioning with the RKE command line, your downstream clusters as well, then you should be able to use these features through the command line, but it's not through Rancher at that point.
Okay, another question was if rollback was also possible to be done with zero downtime. Nargis asked that.
No. And rollback is a revert, and so what's happening there is the database gets put back in, the Kubernetes version goes back to a previous version along with all of its configuration. So it's just as quick, it just sort of rewinds the whole world very, very quickly and starts back at that point. So it's not, and anything that occurred between the time you decided to roll back to that state and is lost, right? Like, so it's just quickly bring the cluster back to that state. There's no running in any type of hybrid state would be problematic, and also just the way that the reason for rolling back in this case, is something is wrong and restoring service is more important than availability at that point.
Awesome. One other question is, Stefan asked a good question. He said, when you're upgrading the worker nodes, we also like to take the opportunity to upgrade the operating system on the update. Is there a way to pause the Kubernetes rollout while we do the OS update under the hood?
Not today. That's not part of the workflow. This is specific to the Kubernetes version. So to do anything on the underlying host at this time, you would need to drain Cordon through another process, clear all the workloads off of it, bring the host offline, upgrade it, and bring it back in. That process would be, is still out of band. With K3S clusters and the system upgrade controller, there's probably some, not out of the box, but using the system upgrade controller directly, there might be something. It's an area that we're interested in looking in, but there's nothing out of the box, and there's nothing that they're not tied together today.
Great question. Rick asked if is there a zero downtime upgrade active for upgrading from 2.3 to 2.4 or from 2.4 to say 2.5 in the future? So for the Rancher itself, can you upgrade it with a zero downtime approach?
So Rancher itself is actually just a Kubernetes deployment on a Kubernetes cluster. And so upgrading Rancher does not require you to upgrade the underlying Kubernetes cluster. It also does not automatically upgrade the downstream clusters. So upgrading Rancher, even if it does go offline, should be a non-impactful event. But again, we're using just the native Kubernetes constructs under the hood, so service should continue throughout the upgrade process, as it's just doing its upgrade strategy is just the rolling update. So the pods should still exist throughout the upgrade process.
Okay, lots more questions, but why don't we dive into the demo, Bill?
Great. So here I have a cluster. I'm assuming you're seeing Rancher right now.
Yes, we are.
Great. So here we have a cluster. Before any upgrade, I like to take a snapshot. And so here we've kicked off a snapshot, and if I come to my tools, I can see my list of snapshots and see that this one is now being taken. I'll wait till it goes active. Okay, so now that I have an active snapshot, I will go take a look at my upgrade. So I'll come to my cluster, I will edit. I see here that I'm currently running on Kubernetes 116.8. And I'll select 117.4. And I will kick these off. So the way my Kubernetes cluster is configured, I upgraded one node at a time. I will be draining them aggressively. Since this is a demo cluster, I don't really have to worry about standalone pods or any volumes that are tied specifically to the host. You have the option to pick whether you'll respect the grace periods or drain timeout. To configure more, in here you can configure the batch size in either an absolute or in a percentage. So for larger clusters, if you've got additional capacity, you might want to go with a percentage so that you can take more nodes offline and you can balance time to upgrade versus your availability and customize that for your situation. To address the worker upgrades, you have to switch over to the YAML editor view. It's an advanced option that we didn't. Most folks we expected to have 3 clusters or three control plane nodes, and so one at a time seems the safest. But if you had to adjust that, you can do it through the advanced YAML editor. And so yeah, we'll just go with a new Kubernetes version, and we'll see. So that is going to currently go through an upgrade. We should see it kick off and start draining nodes. So it's going through and doing its thing. So while this one's going through an upgrade, I did provision another K3S cluster. Let's take a look at that really quick. And we'll talk about that while that's going through, and then we can show what the new options are for reverting.
I've got a bunch of questions too, Bill, if you want to wait a minute, if you want to get to some of them while you're waiting.
Oh, sure.
There's one question that's Nadir asked. He said, "Does the zero downtime also apply to stateful services that are running on the cluster?"
So it depends. So basically, the way it's working is it's doing a drain and cordon on the node. If those services can be moved, safely without, they move and they don't have an impact to their availability. That would keep it up and running. If it's part of it should move those Kubernetes constructs around and be able to handle those as well.
There was another question about versions. Philippe asked if the no downtime upgrade would support upgrading from say 1.14 to 1.16, or would it need to go from 1.14 to 1.15 and then 1.16?
So Kubernetes upstream recommends that has some specific rules about upgrading, and so they don't recommend that control plane nodes run because you're going to be running in a mixed state much longer in the new upgrade strategies. It is the Kubernetes community recommends moving version to version to version, so you can go between any control plane node version. You can have, I think it's n+1. And then between any worker node with a kubelet and talking to that, there's like n-2. So basically what it boils down to is you should be upgrading minor versions one at a time using the zero downtime upgrade because of upstream recommendations and how that works.
And I apologize if I'm missing your guys' questions. There's literally about 200 questions, so they're just coming in really fast. One question that came in, David asked, could you describe the safe mode of upgrading? Do you want to explain what that is?
The safe mode is so Kubernetes has built-in methods of when it does a drain in Cordon. And so when it does a drain, there's certain things that get ignored when draining, and when it and when it makes sense that to move a workload. So in the case of if you allow containers to run with empty dir volumes, that the data that gets written to that volume is now specific to that host. Right? Under the hood, it's creating a local volume on that host, and you're writing data to it. And so when you drain and cordon the node, you can't. Kubernetes is smart enough to know that if I move this, you'll lose the information on that. So it makes it a very conscious choice for the user, for the operator to say, I either care about that data or I don't care about that data. And so there's several sort of edge cases like this where if you drain without the sort of like force and ignore, and daemon sets are another one, and force and ignore daemon sets, then it'll try and drain, but it'll hang sort of forever. And so within those, that's sort of the difference between safe and, or that is the difference between safe and that. So in the safe mode, it could potentially hang, or it in the aggressive mode, it sort of does a more forceful eviction. So the thing to note is between Kubernetes versions, you should assume that when you upgrade from a minor like 116 to 117, that Kubernetes will need to restart all of the pods. And so the reason for when you drain the node and move the workloads, you sort of mitigate the impact of that as things get deployed and rolled out. If not, then basically when you deploy in the more aggressive modes, then you end up having to restart containers. Yeah, upgrades there's a lot going on in an upgrade, and a lot that moves through that. I don't know that I can talk to every detail.
There was a couple of questions about snapshots. One, Lori just mentioned that she's running 2.4.2, but doesn't see the option to take a snapshot. So is there something, maybe that would prevent someone from seeing that? And then Toshukwa asked if, he said right now snapshots have to be taken manually before an upgrade. Are there plans to include the option for enabling an automated pre-upgrade snapshot?
Yeah, it is something that we looked to try and get in, but it just didn't make the cut. To be able to, when you initiate the upgrade, to click save and have it automatically have an option to optionally take that snapshot. At this point, it's the way it's kind of been as a workflow. You go manually in our docs and our recommended upgrade paths that we steer users down. We said take a snapshot beforehand. So it is a nice UX enhancement, and something we can look into getting into a future release. But today you have to kind of do the workflow that was shown. And then there's two parts to that, Shannon. What was the second part?
It was just someone was saying they're on 2.4.2 and they're not seeing that snapshot capabilities. I don't know if maybe is there some kind of cluster they might be running that wouldn't show up for?
It would have to be an RKE cluster that we've provisioned through Rancher in order to be able to take the snapshot.
Okay, that might be why. Okay, why don't we keep moving? I know we got a lot to cover, and again,
Yep. So just this cluster upgraded while we were all talking, and so you can see all the nodes are now on 117.4. And if I thought, oh, that wasn't a good idea, and now when I do a restore, I can look at I can look at the snapshot, and now I can say just restore the database, which in an upgrade situation doesn't make the most sense. I can restore the etcd in the Kubernetes version, or I can restore everything, the Kubernetes version and the cluster config. So this would be the most aggressive, but brings it back to the state, the cluster to the exact Kubernetes version and configuration that it had at the time that this snapshot was taken. So if I click that, it'll go back and revert. And so while that's running, let's take a look at K3s. And again, if you want more information on the K3 setup and the integration, we really did a great deep dive with the engineers working on the system upgrade controller and the team around K3's last meetup. I strongly encourage you to go take a look at that. So now in a K3's cluster, I've imported, and now when I do an edit, I now am presented with these additional options. This is unique to a K3s cluster. Here I can see the basic config of, I can see what was added here. And now I can pick a new version. There's a new version of Kubernetes K3s that's running. I can choose to drain the control plane nodes and drain the worker nodes and the concurrency at which they're upgraded. So the similar knobs that we've given you in zero downtime upgrade have also made it into the K3's upgrade option as well. So from this, I can now click save, and this will go through and upgrade my K3s cluster. So during the rollback, it is fairly aggressive. And this will come back online as it's going through and updating everything over time. So that's the demo that I wanted to show you today. Yeah, should we hand it over to
Well,
Darren?
Bill, there were a couple more questions real quickly. One came from Sudhir. He asked, where do the snapshots actually get saved to? Are these, how do you configure where snapshots go?
So snapshots don't have a cluster up. You have two options. There's local. So if you've got snapshots would be stored on the local host that the etcd cluster is running on, and you can have an out-of-band process take those and move them to a safe location or a shared storage location. The other option is, as part of the cluster configuration, you can configure etcd backups to go to S3 or an S3 API. So if you've got like a Minio proxying to an Azure Blob Storage or another one, or an on-prem, you can use the Minio as an adapter to other providers, if you stand that up. But you can configure it to go to an object store backend. And so this upgrade.
Hassan was asking if you could configure this to point to like SAF or NFS. Is that possible as well? Like any storage?
So it does a backup locally, and so if you did the bind mounts to the directory where the backups are stored, and that was actually backed by a shared storage, then you could do that.
What is the Sergey asked, what is the typical size of a snapshot?
I'm not sure.
Good answer. There was another one asking about Terraform provider, and the question was, if a version change is set in the Terraform provider, would Rancher upgrade the cluster with zero downtime automatically? So is the standard config to use the zero downtime now?
Yes. Yeah, the standard way to upgrade now is through zero downtime.
In terms of the size of the storage, a number of people say it should be megabytes of storage, not massive amounts, as a general thinking. I don't know if that's your experience.
I don't know. I mean, an etcd database can be, I think, up to 2 gigabytes at the maximum size by default. So I think it would largely depend on the size of the cluster and objects that you're running and how many copies you want to keep. But yeah.
There was another question. Benoit asked if the K3s embedded in K3OS is supported as well, including upgrade, or do we rely on K3OS automatic upgrade if you're using that approach?
I'm not sure how those two are related right now and how they would be integrated into Rancher. I think K3OS is still kind of more one of our, it's more of an open source project and not one that we have tested as part of this upgrade integration. So I'm not sure.
Great. All right. Bill, I think that was great. Anything else you wanted to cover or ready to turn it over to Darren?
Ready to turn it over to Darren.
Hey, great job. Really appreciate it. Darren, I'm going to make you the presenter. It looks like you're ready to go.
Okay, let's see. All right, you should be seeing my screen, right?
Yes.
Yep. Yes. Okay, it just says fleet. That's it.
Says fleet. That's you. I see it.
All right. All right. So I'm going to be going over fleet and also be talking a little bit about the new UI too, just because a lot of the stuff I'll be demoing is in the new UI, and then just kind of talk about what we're doing there, like what's the reason for it and how it's different. So fleet is a project we just launched, about maybe 2 weeks ago. This is a very early alpha project. It aligns with, we announced this project right around basically the same time that 2.4 was announced. I think it was the day after, because it very closely aligns with the story of what we're doing with 2.4, where Rancher is headed, what we're kind of trying to accomplish from a much larger perspective. But Fleet is actually a separate component from Rancher right now. It's a very early alpha open source project. We're putting a lot of effort into it. It's gonna, as I talk about it, it's gonna be kind of a key technology for Rancher. So one thing I want to call at the beginning, so the name is Fleet. We went through a lot of different names and ideas and whatnot, and basically what we were trying to build is a fleet manager. Fleet seemed like the most logical thing, but I wanted to call out, because Fleet was a name that was used previously by CoreOS. They had a project that would manage running containers across a CoreOS cluster using etcd and systemd and some pretty neat things. And so CoreOS, that's an old project that's been kind of archived at this point, but we did quite consciously, it's like we realized we picked the same name, and we hope people take that as like, it's kind of a nod to that project of, that was something, a lot of appreciation for what CoreOS did in kind of the early container space, all the innovation they did. And actually one of my first open source projects was built on top of Fleet, CoreOS Fleet. It was actually the project that eventually kind of became Rancher 1.0. So anyways, let's see. So let's go to the next slide here. Okay, so what is Fleet? So basically, the basic idea here is with Rancher 2.4, we're able to do thousands of clusters. So we're able to kind of optimize that code base, the architecture, the approach of what we've done, and we can get to thousands of clusters. And we might be able to continue to optimize that further and get to like 10,000 clusters, something like that. But fundamentally, there are some shortcomings to the architecture and how we approach things in Rancher 2.4. So really what we're trying to accomplish is, how do we get to millions of clusters? And Fleet is basically the technology that's going to allow us to get to millions of clusters. So it is a separate project, and we're going to continue to keep it that way, as something that you can just install and use as a separate project. But it is really designed that is going to be the engine for Rancher. It is going to be heavily integrated into Rancher, and that's how we expect most of our Rancher users to end up using it, as really just an integral portion of Rancher in the future versions. So one of the questions is, why millions? It almost seems like ridiculous, at this current state. Shannon was saying earlier in the meetup that, a lot of our customers are, 100 clusters would be quite large for them right now. So millions seems like a really huge jump. So kind of where we are right now is we're definitely seeing, with kind of like the traditional Kubernetes clusters, people are running hundreds of them. With the introduction of K3S, it kind of changed the picture dramatically, we're now seeing people running thousands of clusters. But it's kind of different because there's thousands of small clusters. But when we look at kind of the future of like where we kind of see Kubernetes going is we really see that it's feasible that basically we could be running Kubernetes everywhere. So you kind of look at it as not just cloud data center, where it's kind of very popular today, but we're seeing a huge demand from basically running Kubernetes like in every store or like every ATM on cars. Like people are trying to actually do that too. So basically, Kubernetes is just becoming kind of like the new app server, the new platform. And it's really been an interesting journey because, it wasn't as obvious to us at first when we kind of got into the edge space of what were the benefits of Kubernetes on the edge, because our initial thought was like, this kind of seems like it might be too big and heavy for the edge. Like, shouldn't we do something that's lighter weight or simpler or something? But when we talked to people who were already kind of doing this, they were really trying to push Kubernetes to the edge. The benefits significantly come from it's kind of the accelerated pipeline of being able to manage and deploy applications. So there's a huge amount of benefits of just being able to plug into like the entire Kubernetes ecosystem and how things, people have been able to deploy things in cloud and data center so efficiently. They want to be able to do that same thing at the edge. When you talk to a lot of people running edge applications, one of the biggest issues is just how do you manage it? Like, how do you ship a new version? How do you update it? For a lot of people, let's say like you're running servers and stores, like pushing out a new update is a major process. I mean, this is like months long. You're having someone come on site. It's cost a lot of money. So basically, there's a lot of benefits of just being able to run Kubernetes anywhere, just from the mechanism, just how do you push and deploy things. So when we kind of got into the space of running, kind of Kubernetes on the edge or just kind of Kubernetes anywhere, there was this idea of like where I think a lot of people kind of logically was, okay, if I have like 1,000 devices, why don't I make that one big cluster and each device is a node? And there's a couple projects that kind of went down that path. In practice, this just proved to be far too difficult, not really practical, because basically it's very hard to scale extremely like large clusters. Like you can do, with Kubernetes, you can do clusters of like 5,000 nodes. But there's a lot of engineering effort to just get that to run, to be able to manage 5,000 nodes. On top of that, there's very significant latency issues around, if you're running all these things in different stores and you have bad internet connections, how does Kubernetes deal with all of that? It's not really designed to deal, it's not really designed to be completely disconnected all the time. It really wants to be connected all the time. And on top of it, it's fairly chatty in the data and stuff that goes across the wire. Kind of the last main issue is if you just run one big cluster with everything every device is a node, is you have very large failure boundaries. You kind of have you can have pretty catastrophic issues. So basically, we didn't see a lot of success in people going down this route. I also want to point out too of like, it kind of seems like, oh, I could just create a deployment and it would go across nodes. But each node is like in a different physical location or whatever, and Kubernetes would just manage that. It's kind of not that simple. You run into a lot of nuances of like, well, I want the application when it's running in this store to be configured slightly differently, or the rollout strategy is not really the same thing of how you want to just roll out a deployment. So like kind of the built-in mechanisms of how Kubernetes deploys things don't exactly match how you're going to want to run things with like, a large disconnected or distributed environment. So basically when we've pretty much settled on the idea of smaller clusters. And this has worked out extremely well. K3s has been very popular in this space. It's way easier to run a smaller cluster from an operational perspective. There's a lot less to worry about. You can build clusters as pretty much like almost like stateless, or you can just focus all your state in, you know, kind of one specific area and kind of lose it. So there's a lot of operational benefits of just running these smaller clusters. They're much easier to run. But the significant downside of a bunch of clusters is like, well, I can't just obviously leverage like a Kubernetes deployment because that's not going to go across clusters. Like, how do I do multi-cluster? How do I manage things? So this is where, you know, basically where Fleet comes in. It's like, well, you know, we found it significantly better to be running a bunch of small clusters. But how do I manage all these clusters? Now I just have like a management issue. And in general, kind of last point is this approach has been proven is working pretty well. I mean, we have plenty of users and customers who are running, you know, fairly large deployments of K3S. I mean, thousands of clusters. Okay, so I mean, that's kind of the justification of like, you know, why do we want to get to millions? And so going back to like, even if you're not like, because I've talked a lot about like Edge and K3S and those types of things, even if you don't want, like, if you're not looking at that use case of millions, like you're still like tens or hundreds of clusters, everything that we're doing still applies. And it's still going to benefit you significantly, because a lot of this comes down to like complexities of like, well, if I have 10 things, I don't want to do 10, you know, if I have 1,000 clusters, I don't want to do 1,000 operations. I want to do one operation to manage all of this. So even if you have 10, you're still going to care about these, you know, kind of what we're doing. Okay, so specific scale challenges that we have in Rancher 2.4, like the reason why, you know, we kind of needed a new architecture, a new approach, is Rancher 2.4 under the hood is really just a Kubernetes application. It follows a controller model, you know, so basically Rancher is just a collection of a lot of controllers that are doing kind of whatever random things we need to do in Rancher. You know, the amount of controllers we've written at Rancher is significant. I mean, I think we've pushed the boundary on a lot of this stuff. We're usually a little ahead of kind of where everyone else is with kind of the complexities and challenges of writing controllers. But in general, as we've grown, like we have a new issue, a new feature, new functionality, we write a new controller. Each controller kind of has a different mechanism on how it communicates to the cluster. I mean, in terms of like a pattern of like, you know, reading, writing, how it does it batch it, does it, you know, do it incrementally? So basically each controller kind of has its own little behavior of how it's interacting with the clusters. And it's bi-directional, like we're from the central control plane making API calls down to the clusters, and the clusters are also, you know, kind of going back up, grabbing some things. So in general, it's very chatty. In a steady state, it's not significantly chatty, but definitely it's like during upgrades or I mean, actually, like Rancher's monitoring a lot of the cluster state that's being pushed back to the central control plane. So if your cluster is doing a lot of changes and whatnot, that's kind of getting pushed back to the central Rancher control plane where we're watching that stuff. So there's just a lot of communication going on. Also in Rancher, pretty much a lot of the operations are oriented towards like you go to a cluster, you edit a cluster, you know, so it's like if I have 1,000 clusters, it's just not going to work anymore. Like that approach, like I can't be doing things individual for each cluster. Now we have a lot of great mechanisms that, you know, like Terraform and whatnot, where you can make that situation significantly better. But we fundamentally wanted to kind of improve that mechanism, because if every single operation you do on a cluster is kind of individual, then let's say if I use Terraform, well, I can create like 1,000 Terraform scripts and I can automate that, but I still kind of have 1,000 things. And then those 1,000 things are kind of disconnected from each other. Like, so then it becomes like the user's problem of like, well, how do I roll out, you know, how do I, you know, I want to roll out this to 1,000 clusters, but you know, 3 of them fail, just stop. You know, so by not kind of building in kind of architectural things where we can have a central view and managing like consistency across clusters, we can't kind of optimize some of those patterns of how we do things. Also, one of the major issues with Rancher when you come to an edge situation is we kind of we require an always on connection. Like if we don't have a connection to the cluster, we'll show the cluster is unavailable. You can't do a lot of things. Yeah, like we're just basically kind of assuming that we can always talk to it. So what Fleet brings in is we have a very consistent approach to managing resources. So no matter how I want to, like no matter what features I kind of want to add and manage in the cluster, I have basically one approach now of how I can do this. And that approach is highly optimized to be very scalable, works across, we don't require a live connection. It can be disconnected. So we're just basically, from writing all the different controllers and all the different things that we've done over time, we've figured out kind of some basic patterns. It's like this works really well, that we can pretty much just manage everything with these patterns, and then it becomes highly optimized. And this is why it's also important for us that like Fleet kind of stays as a separate project. It will be heavily used by Rancher, but it'll still be a separate project to kind of keep the architectural purity of it, in that it's important that, we have this kind of very isolated layer to manage all this stuff. So we make sure that we don't break like kind of any of the scalability, and that we don't bleed in things that kind of break, kind of the approach. So fundamentally with Fleet, all the clusters, they just download their desired state, and then they report back their status. So there's not a requirement of like basically it's not built into the mechanism that the central control plane is making live API calls down to the clusters. Like that causes a significant amount of scale issues. So it's more of the clusters are pulling their state and then they're reporting back. We do have mechanisms to get like a live connection to the API for like debugging purposes and whatnot, but for the most part, it's kind of like check in, figure out what I should be doing, apply that, and then report back. Okay. So the basic architecture, so kind of from a concepts perspective, we really have two high-level things that we're looking at. It's bundles and cluster groups. So bundles, the idea of bundles is it's just a collection of Kubernetes resources. So we have like built-in integrations for managing just regular Kubernetes YAML, Helm charts, and anything based off a customized tool. Combining these three approaches, we've seen it works pretty well. I mean, this is like kind of the way we built the bundles, and the bundle concept is based off of a lot of just observation of how people have been running things at scale. But you can kind of choose which one you want, and there's pros and cons to each approach between just like raw manifests, Helm charts, or customized. So there's kind of each one, is good and bad. So fundamentally, like in the Fleet controller, you're deploying bundles, and then we're going to deploy. You define bundles, and then we manage the deployment of those bundles down to cluster groups. And we very specifically called it bundle, is because like it's just a group of resources. We didn't want to call it like app or any other kind of first-class concept like that, because it's extremely flexible. What we can do is because we're being able to define basically everything as a Kubernetes resource. So it's not just applications, it's infrastructure, it's like all this, all this other things. So it's like with this mechanism, we can kind of basically do everything. So it's like I'm deploying your applications, I'm managing the version of Kubernetes, I can manage the version of the OS under the hood, because these are all like kind of through the power of like the operator pattern and stuff like that. It's like everything's just a Kubernetes resource, and you can create these operators, which then do other arbitrary work. So that's the bundles concept. So then we have cluster groups, and cluster groups are every cluster is a member of one cluster group. And we do that as like from a very high level perspective. It's easy to see like big groups. So if I have 1,000 nodes, I have 1,000 nodes in one group. And the clusters in that group kind of have a shared identity to a certain point of being tied to, like, as we integrate Fleet more with cluster provisioning, the cluster group concept will make a little bit more sense. But even though, like, as I said, a cluster is a member of one group, when you deploy bundles, it's all based on selectors of clusters. So it's not actually tied directly to cluster groups. The cluster groups has more to do with like the management of the cluster and reporting an aggregated status. But okay, so those are high-level concepts of bundles and cluster groups. And then kind of the architectural components is basically we have a fleet controller. This is the centralized component that is just it's a Kubernetes controller, so it runs on a Kubernetes cluster, and you communicate with it through standard Kubernetes API. So a lot of effort was put into basically, even though we're trying to scale to millions, and people are very skeptical of this, of like, well, how do I get a Kubernetes controller to scale to millions? I can kind of talk about some of that stuff later. We put a lot of effort into making sure that this works with purely standard Kubernetes APIs. And the security model is completely native to Kubernetes too. Because as we're creating clusters, the clusters have to join, they have an identity, they get, managing, who can access what and the RBAC and all that stuff. Like it's all natively managed by the fleet controller using basically service accounts and role bindings. So the authentication mechanism for the clusters, like how the agents authenticate and communicate back in, is actually through managed service accounts. We're doing kind of all that automatically, which has the benefit of this fleet will run on any Kubernetes cluster. It has no specific tie-in to anything that's Rancher. It's not tied to RKE or anything. This is just standard Kubernetes. It runs with anything. Any modern like 116 or 117 cluster. Okay, so that's the fleet controller. Then we have the fleet agent, which is basically you have one per cluster, and the agent is basically which is looking at the desired state from the fleet controller. It deploys the bundles, and then additionally, once the bundle is deployed, it watches the resources to make sure that they're ready and that they haven't been modified. So you can know that everything is consistent. Fundamentally, the bundles are actually always deployed as Helm charts. No matter what the input is, if it's YAML, Helm, or customize, the end result, even if you didn't start with the Helm chart, we dynamically create a Helm chart and we deploy everything with Helm. There's a lot of advantages of doing this. It's very tricky to be able to automate Helm, but there's some advantages of basically, you can go into the cluster and you can do a Helm LS, and it's like, everything that we're managing from a fleet perspective is going to be tracked in a chart. You can see the history of how those were updated over time. You can very easily audit it by looking at the chart has what's its desired state. You can check if it, so there's a lot of advantages of the metadata that is stored with Helm charts. And that's largely why because we went down an approach first that wasn't natively Helm, and we just kind of realized it's like, well, we're just duplicating a lot of the effort, basically what Helm has done, because you really want, like, once you deploy something, you really want to keep an inventory of what was deployed. It's the same thing of like if I was installing something with a Linux package like an RPM. You have a metadata state of like, well, what should that package be? And so Helm is doing all of that. But even if you don't like or want to use Helm, like, and you just want to use like YAML and customize, that's fine. You're not having to interact directly with it. Although we do have a lot of nice integration with Helm. Okay, kind of the project, the status, roadmap, kind of where it's going. This project, it's very early alpha. I'm sure there's plenty of issues with it. There's the UX is very raw because it's just pure Kubernetes APIs. We haven't really put any effort into kind of making it super pretty and usable, like most Rancher projects. So it is kind of raw. It's a little bit more advanced for people to pick this up. It is an external component. It's not integrated into Rancher right now, but it is going to be, like, we're doing all the effort now of integrating this into Rancher 2.5 and then moving kind of everything in Rancher over to bundles. It's like everything that we're managing, like let's say like RBAC and stuff that we're managing in Rancher, it's like it will end up being kind of a bundle that then gets deployed. So you can actually see very easily how Rancher is managing your cluster, what resources are coming from us. Like if we're dynamically generating resources like RBAC, you'll be able to see that very clear picture. So it's like it's a very controlled approach. Yeah, and so a lot of the development effort, it's like the initial functionality that we have in the project right now, it seems to be pretty good. We've gotten a lot of feedback. You know, as people try it out, we'll see. We'll see. I'm sure there's going to be major flaws or, you know, whatever. We'll figure it out. This is an early alpha project, but a lot of the development of Fleet, it's kind of like our roadmap. What are we doing? What are we adding? It's right now we're largely focused on let's integrate this into Rancher, and then that's going to bubble up basically a lot of like what are the shortcomings of it. Okay, I'm going to go into a demo of Fleet next. Before I go into the demo, I'll talk about the dashboard just so you a little bit about that. Shannon, I don't know if do we want to take any questions now or what do you want to do?
There's a load of questions. I would say, you know, many of these are kind of, you've covered different parts of them. So I would suggest, especially given the time, why don't we get through the demo and then we'll ask the questions at the end.
Yeah, okay. So I'm going to be showing a lot of this through the new UI. Denise also showed the new UI from OPA. The new UI, it's early. You know, we're still ironing out a lot of kinks and prettying up the UX and CSS and all that jazz. But basically, the reason why we're building a new UI is fundamentally the problem we have with our current UI is it's actually not the UI specifically, it's more the backend powering the UI, is that every time we want to support a new Kubernetes resource or a new type, we have to put some development effort into that. So you know, I want to show deployments, I want to show this new thing like OPA, we have to put like a certain amount of development into being able to show those resources. And so the new dashboard, what we're doing, it's fully dynamic based on the resources in Kubernetes. So if we don't have, like if you just have a cluster, you can just point the dashboard is actually technically installable outside of Rancher too. But I'm not going to go over that. But with the dashboard, it just basically, it looks at the Kubernetes API, figures out what are all the resources, the types, the versions, what's the open API schema. It uses full discovery and then builds the UI based off of that. So if you add new types, like new custom resources, you know, we can present a very nice UI and a very nice experience. It's just fairly generic, but you can still interact with anything in your cluster. And then for types that we know about, you know, the built-in like core types, pods and nodes and deployments, or, you know, things we're doing that are specific Rancher features like OPA, those we can build customized UI for. So on top of that, so it's dynamic, you know, we introspect all this stuff, but then also on top of it, the UX, it was really important to be able to show multiple namespaces at once. So I'll demo that as we go through the UI, basically how you can, you know, kind of see resources and stuff like that. Okay, let's get into the demo here. Okay, oops, let me see. I might have to re-log in. Like, just check some real quick. I'm SSHing into another machine. But I think like the connection types out or something like that. Okay. Oh no, there we go. Okay, we're good. Okay, so for this demo, basically, let me bring up the UI here. So the way you get to the new UI, you probably already saw this quickly when Denise demoed, but basically when you go through, oops, come on, go internet. Okay. When you go into a cluster, there's just this link here for try dashboard. If for whatever reason you want to disable this, you can. You just go into like the global settings, there's a feature flag and you can turn this off so then your users won't have access to the new dashboard. But it's there. So basically, so what I'm showing you here is I'm looking at right now the Fleet controller cluster. So this is the central cluster where I've installed the Fleet controller. So I'm going to go into the dashboard for that cluster and show, and I'll be able to see the types there for Fleet. So just to kind of orient yourself on this new UI, basically what we have here is at the top, This is where we can select what namespaces of resources we're looking at. There's, we will kind of dynamically detect if you have projects in your cluster, like a rancher concept projects. Projects are in no way required. That's kind of one of the, you know, kind of, I would say issues with the current UI is it's very heavily oriented towards projects. While they add a lot of great functionality and a lot of people like them, if, you know, like a namespace isn't in a project, then you can't see it in the current UI. So our new UI, it will respect rancher projects, but they're in no way required. But you can also, there's a bunch of kind of like different selectors of like, I want to see all namespaces, or I want to see system namespaces, or just namespace resources, or cluster level resources, or I can select a project, I can select, you know, so let's say a namespace, I can select multiple namespaces. And as you do this, basically, you know, what's available to you will change. You can see these counts here. Like, so if I go and I say like all system namespaces, it shows, okay, these are all the new resources. What are the counts? What do you have available? So, you know, with these concepts, you can very easily navigate, like, because like the kind of my complaints with other dashboards or UIs or whatever, is you're constantly switching between namespaces, or you're going from global to namespace. Because a lot of times you have projects that might span multiple namespaces. And so we really put a lot of effort into being able to do this across namespaces. Okay. But so at the top here on this UI, you have basically, this is where you can see what namespaces we're looking at. On the left here, this drop down, this is if you have multiple clusters registered in Rancher. Right now, I'm just looking at the one central fleet controller. And then here is basically, these are all objects that exist. So it's in use objects. Basically anything where the count is greater than 0, we automatically just kind of show here. And these are kind of friendly names, but these are pretty much all grouped by API groups. So if you put in like a new API group that we don't know about, then you'll just see the API group of like, you know, foo.bar.io or whatever. And then so that's whatever is in use. And then you can also just get to any resource that exists in the cluster just through the search here. So it's like if I want to whatever look at add-ons, which I don't have any of these, then I could go to that. And then once you have when you're looking at, let me show you like something like deployments example. So any resource you can just automatically create from YAML. So Vincent, our UI architect, he's a guy who does the kind of the lead of all the front end, put a lot of effort into this little YAML editor, which is really cool because when you go and let's say you create something from YAML, we automatically look at the open API and give you like, you know, kind of what are the examples of all the different fields. If it's a required field, it's not commented. You know, you have to fill this out. But this makes it super nice of like being able to just be able to create something. And again, this is all dynamic. It's not based on like we programmed this logic, like the structure of a deployment. It's all based off of the Kubernetes API. So if you create custom resources and your custom resource have open API schema, we dynamically look at it and we'll create all this for you. So like editing the YAML and stuff makes it a lot nicer. But here for like deployment, here's an example of you know, there's the generic approach of just YAML, but deployment, so we actually have like custom UI for you know, for creating a deployment. Okay. Hopefully that's a quick rundown of this new UI, so you kind of understand what I'm doing as I'm clicking around and doing things here. So there's also the section here for starred, which is you know, kind of like you can just star anything and then it'll stay in here. So I've kind of already gone through and starred basically bundles, clusters, and cluster groups, because these are the resources that we're going to be looking at as I'm doing this demo. So right now I have 2 cluster groups and each has 100 clusters in it. So whatever I'm showing you here, like this exact same stuff is what you're going to see in, if I say like K is just an alias for kubectl, get cluster group. Because I just want to call out that like whatever I'm showing here in the UI, there's no specific logic in the UI. We haven't built any custom UI for this. This is all based off of the types right now. So it's like you'll notice when you say kubectl, the columns that come, the UI has the exact same stuff. Okay, so I have two clusters that have 100, or two cluster groups that have 100 clusters in them. Okay, so these clusters are not actually real clusters, they're simulated clusters. So I want to kind of call this out because like our objective is to get to 1 million clusters. So how do you actually test 1 million clusters? It's significantly difficult if you have to have real clusters. So from the very beginning, we built a simulator, but it was really important that when the simulator that we built, that it was not kind of fake, it wasn't arbitrary. Like, so what our simulator actually is all we really do is the agent that we would run in one cluster, we can just basically run X number of those agents in a cluster. So the behavior of the simulator is, I mean, almost exactly the same as how a real cluster would behave. And this has allowed us to very efficiently and very easily test, you know, some of the aspects of Fleet Manager. So like we've tested Fleet Manager up to about, or we've tested Fleet up to about 10,000 clusters right now. Like that was fairly easy to do with a limited amount of resources. It didn't really take much. Just spun up like one 64 gigabyte server. Oh, actually, we didn't even say, it was like 32 gigabyte server, and we can manage 10,000 clusters. So it's pretty easy. So we're trying to do 1 million next. That's significantly harder. So we need a little bit more resources for that. So that's kind of where we are. But so I didn't want to call it, like I am actually using simulators right now. These aren't real clusters, but it's like the simulators are very kind of real in terms of the behavior. And we're continuing to kind of put more effort into ensuring, you know, like being able to do random failures and stuff like that, so we can test all these various conditions. Okay, so I don't really have enough time to go over like all the functionality of the bundles. I would highly, like, if you know, if you're interested in using Fleet today or trying it out, you know, I did my best to kind of document this stuff. There's this one page here, which is kind of understanding bundles and how bundles are structured, how it works under the hood, all of the various configuration you can do, the different like rollout strategies and resources and whatnot. There's like, it's very customizable because the whole idea is like you have a bundle, and a bundle targets some clusters, but then based on that cluster, it needs to be customized somehow. It needs to be changed. And there's a lot of different approaches there, and we're adding more features there too. So it's like I really don't have enough time to go over all the functionality. So we're gonna kind of gloss over a little bit like the details of the bundle. And so I have a very basic bundle right now, which right now just has one manifest. I'm just deploying a config map because that's super fast. Normally, if I deployed like a pod, every deployment will wait until that's ready, and you know, so it takes a couple seconds for the ready check to go, or whatever the readiness probe is configured for. So that would slow down things a good amount. So config maps are super fast because they're just immediately ready. But you can also manage this all too with like, I'll show you some of the parameters around like max unavailable and stuff. So you can basically control what the size of things are. So going back, so I have this one bundle here. So if I go and I look at this bundle, I'll just click on this here in the UI. The bundle it's fundamentally just a Kubernetes type. It's one type. It's just one YAML. And the bundle, it has basically all the content of what it is embedded in it. This makes it really nice from a management perspective. It's like we have one resource that has basically everything in it. And we do a lot of kind of fanciness of how we distribute these, the content. But it is kind of annoying from the perspective that it's like, well, you have a YAML with like YAML embedded in it. And so one of the main things that we've done right now with the CLI is the CLI will basically take a flat directory, like a directory structure of files, and basically grab those files and then put it into the Kubernetes type that we're expecting. So it makes managing this a little bit easier. But at the end of the day, I just want to call it, it's just this one type. It's just, it has all this embedded content in it. So if I go and I edit something, I can just say fleet apply, and it will basically take this content on disk and it will create the bundle, and it automatically applies it. If you don't want to apply it and you just want like, well, what's the Kubernetes resource that gets created, you can just say -o to a file, or dash means standard out, and it will create this resource. So you can see this is what I'm actually doing here. So if I go and I edit, if I look at this bundle, I have it targeting right now 2 different selectors. One is US East, and then this one US West, but there's a -x. So basically this is not going to match anything. And so if I go and I look at how this bundle is deployed today, I can see, okay, this bundle, it's desired to be installed on 100 clusters, and there's 100 that are ready. So it's like everything's happy with that. If I go and I look at the cluster groups, I have these 2 different cluster groups. I've deployed 100 of these to US East and none to US West, because this bundle does not match any selector in US West. So if I go and I change this selector, do this, and then fleet apply, now it's going to start updating. And so you can see over here in the status, there's, again, the UX is very raw right now because it's just kind of like the raw API. But we're tracking, like you can see, not applied means it's like it should be applied, but it hasn't been yet. Not ready means it has been applied, but it's not yet ready, like we haven't checked. And there's other statuses of like out of sync or modified. We'll see some of those in the demo. But basically, so we're going through here, and so that just updated 100 clusters. That just rolled it out and did 100 clusters. That was super fast, and one of the reasons why it's running so fast, if you look here, it says max available is 100%. So I did that for the demo because it would run super fast, which max unavailable means that basically just blast it out to everything all at once, which is pretty much what you never want to do. But for the demo, it's great. So I'll show you what the behavior of, so if I go, let me just comment this out. I can go and basically, so I'm just going to go to the default kind of deployment strategy. And the default deployment strategy is based on partitioning clusters. So we figure out, okay, this bundle needs to go to these clusters. Then once we have the group of clusters that we want to go to, we then partition it. And there's different strategies on how to partition. And then we manage like each partition of deploying it to that partition. And so an example, like we do this automatically, like there's a default behavior, but it's very configurable, so you can do this manual. But the default behavior is basically we just take the whatever your set of clusters is, we do 25% of that is each partition, so you end up with 4 partitions, and then basically we won't, we'll start with 1 partition, and as long as everything goes fine there, then we move on to the next partition. So a more realistic scenario of how you might leverage this is what you can do is you can create like a canary group. So I have like 5 clusters that I want to deploy everything to first. So the canary group, you would deploy that to that canary group. First, make sure everything went successful there. As long as that's successful, then it'll move on to the next partition. Your next partition might be, 10% of US East, and then the next partition might be 10% of US West or something like that. But then you can also change the behavior of like what's the max unavailable within that partition. Because if I'm deploying to, let's say, 1,000 things, there's a good chance like one or two of them are going to fail. Do I need to to stop the deployment completely because I have a 0.1% failure rate? That's just all depends on what you want to do. But you can configure that. So basically you could say like, well, I need 100% success rate on the canary cluster, but then once I start deploying out to like these larger batches, like I can tolerate like 0.1% being down. And so this is all configurable through the deployment strategies. And so I'll show you real quick, like let me just go and update this, and you'll kind of see this a bit in action. It's still going to go fairly quickly, but I think we can kind of catch it as it's happening. So when I write this, so I just edited that config map, and then I'm going to do fleet apply. So when I do this and I go back to the UI, it's going to start deploying things. And so basically you can see, let me see. Okay, it's a little easier probably if I show you the actual bundle here. Okay, so in the bundle, if we look into the detailed status, it will actually show you, okay, here's the partitions. So I've got, sorry, YAML is kind of annoying sometimes to read lists. So I have like a partition here, and then a partition here, and then a partition. So basically I have 4 partitions. These are auto-generated partitions. Again, you can do it manually based on selectors and all those other things, but these are the auto-generated ones. So you can see here that basically what it did was it started with this first partition and started deploying things. And so you can see like not applied and out of sync. So what out of sync means is it really should be this version, but we have yet to actually set it to that version, either because it's been manually paused or because, you know, telling it to upgrade to that version would put us in a state where we've like exceeded the max unavailable count. So here, basically we have like these ones which are applying, these ones which are out of sync, which means they're pending to be told to apply. But basically we're going to go through and we're going to roll through the partitions, and then you can actually even set like what's the max unavailable partitions. So you can tolerate like one partition failing and then still continue going forward. So it's super configurable. But these are like, I hope you can kind of appreciate kind of like the deployment strategies that we're doing for like running across clusters is kind of different from how you would just do a regular like Kubernetes app deployment, like running pods. And this is why kind of like, you know, we really had to develop kind of new technology. Like once we moved up this one level of abstraction of clusters, it really kind of changed the behavior of how you want to do a lot of things. Okay, so this is still rolling out. So because it's going to take some time because of the max unavailable, like the default behavior is we partition everything by 25%, and then we allow 10% max unavailable, which basically means you have a 10%, like we're only going to upgrade 10% at a time. So like you have to kind of roll it out. So when you do this, it's going to slowly roll out until eventually, you know, we get to you know, the desired state. Okay, yeah, so we're eventually there. So you can see that it took a little longer, but it's taking as much as time as effectively I want it to take. You can pretty much calculate and figure out how long it's going to take to do the updates based on like what's the average time of just upgrading one, and then how many can you have unavailable, what's kind of the batch size. But so I wanted to show something where it's like, okay, well imagine like I go in here and I just completely screw up the bundle, like it's completely wrong. Ideally in this situation, we should probably pre-validate the bundle before we even deploy it, but just the state of the software, we do actually push it down to the cluster. But I'll show you when I run this. Okay, so basically it pops up and you can see error applied. Like we tried to apply it and it failed because like the YAML was just bad or whatever. But basically what's going to happen now is because we've hit our max unavailable count. Let me go back to the bundle where I can see kind of the detailed status. So you can see in this partition, basically 5 of them have failed, and then 45 are out of sync. So again, out of sync means it's pending. Like we need to update it, but we haven't really told the cluster fully to update yet, because if I told it to update, it would make so the max unavailable is 10%. So you can see like this partition has 50 clusters in it, and 5 of them failed. So now we're stuck. Like it's not going to move forward because we exceeded our availability, like whatever our kind of like objectives for our unavailability are. So you can see, so this, you know, it identifies the issue, something went wrong, and then it stops doing stuff. So let me fix that, and then there's just one last feature I think I want to show, and then I think I can probably wrap up the demo at that point. So let me apply this so we get back to a good happy state again. Okay, everything's in sync. So the last thing I wanted to show was this thing is once we've deployed the resource. So if I go back to here, so in my bundle, you know, I'm just deploying this dumb config map. I've set the value as value 1. Okay. So here I've opened up, I'm doing a kubectl edit on the resource in the downstream cluster, and I'm going to go and I'm going to modify that. So I've now changed it to value 2. So now if I go back, you can see, okay, this is modified. So I can see in this cluster group, this application or this bundle demo has been there's one instance of this bundle that has been modified. If I go to the bundle here, it gives me a little bit more information, which is basically saying this one's modified. This is the actual identifier for the cluster. Now I can then dig down the next level of detail, which is, okay, every cluster that gets created, so I have 200 clusters. Each cluster, we create a namespace for it, and we put what's called a bundle deployment. It's like the actual instance of that bundle for that cluster. We put that into the namespace, and that's how we track the individual status of the deployment for the bundle. So if I go back here and I say, okay, well, this is the cluster, basically, let's see. That's not gonna work, copy. This is the cluster. I should be able to, let's see, yeah. Okay, so this is the namespace for that cluster. And then if I go here and fleet, you can see, okay, here's the bundle deployment for that specific cluster. And so you can see here, this one, it will show you, okay, that resource, config map v1, that's the namespace, and the name has been modified. If I click into it, you'll see the status here. It will actually tell me, this is the patch that needs to be applied to get it back into sync. So it will, it identifies that this, this has been modified after the fact, by user or something or whatever. It immediately identifies it. And so everything that I've shown so far, like this is all, everything right now has a live connection to the cluster, but this all works if it's disconnected too. It's just we're not going to get the status until the clusters connect. So if the clusters can keep a live connection, everything is dynamic and happens pretty much immediately. If it needs to be disconnected, then it'll just be offline until it can check in and then get its state and update it. Okay, so I think that's like the kind of the majority of what I want to show. Honestly, we could probably have a whole meetup dedicated to just fleet. There's a lot more functionality, a lot more things you can do with bundles. There's a lot of really interesting patterns. But yeah, so this is fleet, I guess.
Darren, thanks a lot for diving in so deep. I kind of held all the questions because I thought it, sometimes quicker to just go through it. I do have loads of questions, so thanks for getting through that. I want to just realize that we're 2 hours and 20 minutes. So I know for a lot of you, we probably stayed on a lot longer than you were planning, but it's awesome to go through so much stuff. It's kind of fun to get back to doing these. One of the let me start with some of the questions that kind of came through at the beginning. Simon asked if the scope of fleet includes provisioning on bare metal, especially like installing the OS and K3S to onboard new devices automatically. Maybe you can chat a little bit about that pattern, because I think it's an interesting one we're hearing about.
Right. So so the scope of fleet is largely right now just focused on managing the Kubernetes resources within a cluster. So then there's the whole question of how to do cluster provisioning, and that's largely what Rancher does today. So it's a little bit outside the scope of fleet, the cluster provisioning, but it overlaps. And the reason for that is like what we're doing, like the patterns that we're developing now for provisioning clusters is based on like cluster API, like the upstream project. We're doing a lot of work in that realm. Cluster API, we also have things like the system upgrade controller. So basically we're managing the provisioning and the upgrades of the cluster and everything with Kubernetes resources. So it's kind of indirectly fleet can then manage how you deploy clusters and do that. So it's like, it's something that we're actually going to be doing, like leveraging fleet to be doing that. But I feel it's a little complicated to explain because it's kind of like a meta or a second order thing where it's like, you're using a system to deploy a resource, which then deploys, so there is like a pattern for it, but I'd say like right now the scope of Fleet, like if you're just going to pick it up and use it, it's pretty much oriented towards managing the Kubernetes resources in clusters. And so like the installation, I didn't go over the installation, but it's super easy to install Fleet. Everything is just a Kubernetes manifest, but the CLI just makes it nice where you can just say like Fleet install manager, and that gives you like, that's the manifest you need to apply. That will give you, actually it should be called, well, yeah, anyways, so Fleet install manager, that installs the controller. And then there's Fleet install agent token, which is basically generates the agent configuration. Like it's going to generate, this command's a little longer. You put like server URL and crap like that. So yeah, so this basically then generates like the YAML that you need to apply to clusters so you can register the clusters. So it's pretty much like just registering anything in. So it's like any clusters you have today, it's pretty easy. You just register them into Fleet Manager. Yeah, and you can go.
Awesome. Another question that came in was Laszlo, he asked if it was possible to make one bundle over mixed Kubernetes environments, means like native AKS, GKS, EKS, K3S, VMware Kubernetes. Like, can I make
Yes.
a bundle over those?
Yes, very much so. Because Fleet is operating at this level of pure Kubernetes. Like it's not, because like when you start talking about like it's, AKS or VMware or whatever, like that's kind of how you got the cluster or the cluster provisioning aspects, which are very specific and different to the infrastructure. But Fleet is managing everything at a cluster, like a pure Kubernetes perspective. So it does not matter what Kubernetes cluster is, how you got it. I mean, you could be running, like you can use Fleet to manage like an instance in kind, or like Docker for Mac or something like that. So it's like, it doesn't matter. It's just a Kubernetes cluster to us. So it is specifically, that is like an objective to be able to take effectively heterogeneous infrastructure and then manage it in a homogeneous way.
Awesome. Ludovic asked if there was a plan for multi-cluster app to be replaced by bundles, and will Fleet replace multi-cluster app in the long run?
Yes, yeah, it will. It basically, it's kind of like a supercharged version of multi-cluster app. Multi-cluster app has some like concepts around like global DNS and stuff, which we have to then have a corresponding solution for, because like the multi-cluster app was a little like it was oriented towards apps. This is a little bit higher and more generic, but it is going to replace like the current multi-cluster app that we have today. This will end up replacing it in a future version of Rancher.
Here's another question. Rishikesh asked if you could remove a C group from a bundle, and can a C group be part of two bundles?
Yeah, so bundles are mapped to, so bundles are just like the targets for where a bundle gets deployed is based off of selectors. It's not actually tied directly to cluster groups. So the cluster group has a little bit more to do with like a management perspective. So yeah, it's very flexible of that. The bundles can just basically select whatever you want. So whatever, like it's kind of important that you put proper labels on things. Or you kind of have a labeling strategy, because if it's in this region, you should probably label it with like a region and an availability zone or whatever. So you have to kind of put a little thought into like, how do you want to label things? But then you can then just select the labels. And like by default, we put a name label on everything, so you can just select specific clusters if you wanted to.
There was a question from Guy, and he asked if, can you just clarify how this fleet management approach and the future view of multi-cluster management within Rancher will be coming together, and how much you see this technology kind of aligning into Rancher 2.5?
Yeah, so Rancher today is already a multi-cluster manager. The fundamental shift you'll see as we integrate this technology into Rancher is really going to be twofold. Is right now, like when you're looking at clusters, you get a list of clusters. That doesn't scale. So you will now be able to deal with things as cluster groups instead of just clusters, or a selector of clusters. So we are now being, like, from a UX perspective, it's going to be a lot more oriented towards grouping and tagging clusters so that you can manage them as units. So that's the one thing that's going to change. The second thing that will change as we go forward is, right now, a lot of the user experience of managing clusters, even though we do multi-cluster management, if you want to change something for a cluster, it's kind of like you click into the cluster, you turn on Prometheus, whatever, whatever tool or feature, is we're going to be moving all that functioning up one level, kind of like to the global level, where basically you can define and say, okay, I want monitoring to be turned on this group of clusters, and it should be configured this way. But then, for these two clusters, I want it to be slightly different and configured differently. So it's like moving the configuration and management up one level, where we're kind of trying to abstract you away from getting into the clusters. And this is just kind of like a larger story that, we're kind of pushing from a rancher perspective of trying to treat clusters more as cattle, and kind of get you out of being so attached to the individual cluster. Instead, we're going to be able to group and tag these things and apply policies, and kind of make them consistent and everything. So it's going to, from a user experience perspective, it's kind of like we're moving up one level. Yeah.
Awesome. If we add a cluster to a cluster group that's already in place and already has bundles, will all the bundles of that cluster group be applied automatically to it?
Right. So again, it all depends on the selectors of the bundles. So again, the bundles don't really target the group directly. It targets the labels that are applied to the cluster. So if the cluster comes in, with certain labels, then and it matches, then you can tag that, and then it will like dynamically apply. So basically, you can set up your policy, I'm saying policy generically of like, it's like, I want every single cluster to have Aqua installed, something like that. So I set up a bundle, which is Aqua, and it has a selector of everything. Or maybe it's a selector of everything except for development. Development, I'll let it slide. So if someone registers a cluster with those labels, then it will get applied that policy. Now, there's some little nuances there of, this is kind of starts to explain a little bit why we have cluster groups and we have clusters, is because technically you can also match the labels of a cluster group, because when a cluster comes in, it defines its labels at that time. So like the cluster can basically set its own labels, whereas a cluster can only join a group and it has no way to influence the labels of that group. So for something like a security perspective, you probably don't want it based on the labels coming from the cluster, because somebody can modify those labels, whereas the cluster group you can't. So there's some little nuances around that, how that works when you start getting into very controlled larger environments.
Another one is there's kind of two similar questions. One, Richard asked if Fleet supports global server load balancing, and Pranav asked if you could use bundles to manage networking policies or security policies or other sort of extended policy stuff. You want to just maybe kind of hit both of those?
Yeah. So there's no global load balancing like natively within Fleet or anything. So it's like Fleet is just basically going to be able to deploy something in a consistent fashion. So one of the like kind of killer demos I've been trying to put together is having Fleet deploy multi-cluster Istio really easily. It just kind of shows all the power of Fleet. But in that situation, it's like, well, we're not doing any type of global load balancing, but we can manage the configuration of it such that we can deploy a component for it. So there's nothing natively in there, but like Fleet can definitely enable something like that. There's some more advanced concepts, things that we're doing more advanced features that were in development for Fleet right now, which is things where it's like, when I create a bundle, the bundle has a certificate, and then we can, for every instance of that bundle deployed in the cluster, we can then have a assigned certificate for it, so we can authenticate. So it's like something like Istio, where it's like we can get identities and stuff like that, and or things where it's like every single cluster has to have a different subnet. Therefore, we need to have kind of like, what's the pool of available subnets? So each bundle kind of gets grabs a resource out of that pool. So there's some like pretty powerful things that we're working on there.
Awesome.
The second question was on network policy, and yeah, very much so. It's like that is a primary use case of Fleet.
Great. And then there was another question. Faisal asked if it was possible to duplicate a cluster group within Fleet. And I'm not sure exactly what duplicate means in that context, but any idea?
I mean, I would say no. I mean, I don't know kind of what that would mean. I mean, a cluster group it's a very simple resource, which has a name and labels on it. That's really about it. And then clusters become members of it. So to duplicate a cluster group, again, we're not doing, like, Fleet right now has nothing to do with the provisioning aspect. So it's not like I can just copy my clusters. It's something has to provision the cluster and register it with Fleet, and then Fleet will manage it. So this is where, I think like that type of ask will make a lot more sense when Fleet is fully integrated into Rancher, and then we can leverage all the provisioning aspects of Rancher plus the management aspects of Fleet.
Awesome. There is still a bunch of questions, but I'm going to have to kind of call it there. We're going to just keep going. Why don't I take back control for a minute, and we'll kind of go through a little bit of close up, and then if there's still questions, we'll dial into those as we go. So hopefully you guys can all see my screen again. And again, thank you, Darren, for sharing all that, diving into it, and providing so much insight into the early workings of Fleet and that project. As we said, it's still very early. It's in GitHub. It's like everything open source, so contributors and commenters are welcome. Really would love it if people would try it and provide some feedback on it. With that, I'll kind of switch to kind of just wrap up pretty quickly. If you haven't already, there was a lot of questions about how to get started, and a lot of kind of early questions on using Rancher. Dive into our docs, rancher.com/docs, docs.rancher.com. You can find it in either place, and there's a great quick start guide that will help you get set up with your Rancher deployment. The other thing is, just it always seems like I need to say it a couple more. All of this is open source, so please, try, use, run, use it as however you like. There's also some great weekly trainings for people who are new. We have a weekly training that's run every week. You can find it on our website really easily. Please don't hesitate to dive in. We talked about a lot of these today. There was discussions. We keep pushing these open source projects out to the community. We talked about Rio today, and RKE and K3S and Fleet. A little bit about K3OS, Submariners, another exciting project we've been working on to connect the overlay networks across different Kubernetes clusters, something we see as being important in the long run. There was a question about Longhorn that was asked about when that's coming to GA, and it's very close. I should expect it before summer that we'll be announcing some the 1.0 availability and production availability of Longhorn. So excited on that. Lots more that we're working on as well. So love any insights or thoughts you have on these projects, please don't hesitate to reach out. And with that, I'll say thank you to all the presenters. Thank you to the hundreds and hundreds and hundreds of you who attended today. It's fantastic to be doing this again. So if you have any remaining questions, I'll take a look at them now. But with that, I'll kind of wrap up the main portion of the meetup. All right, let me just pop this out and see what's remaining in terms of questions. There was one question that Darren that Chatyana asked, and he said, is it possible to plan for disaster recovery with Fleet in production, like switching between data centers? I don't know if maybe that kind of extends the global load balancing conversation, but maybe you can just touch on that for a minute.
Yeah, so that's actually been some excellent feedback that we've gotten as we've presented Fleet to people. So right now there is no specific functionality for DR, but it seems to be a very kind of, yeah, it seems to be a common ask that we're looking at, what are the strategies that really make sense there. I mean, DR is kind of can be a little tricky in terms of fail over, fail back. When do you trigger DR? So we're looking at strategies which are a little bit more like you can have a bundle that has kind of like a DR profile, so it's like basically you can just kind of flip that into a DR mode. Like that's kind of a manual thing, and then it will run in like the failover mode. But yeah, so this is something that we're looking at, and like it's been great feedback, but we don't. Yeah, it's still we're trying to kind of figure out what that really means, like how to design kind of features around it.
Another question was, Hassan asked, is it fair to consider a cluster group basically as like a region in AWS terminology? Is that the parallel you're looking for and you're going for with this, Darren?
No, so the cluster group is like the cluster group. It could be a region, or it could be a subset of a region. It's really up to you. It's just there's kind of an assumption that a cluster group has a certain amount of it's homogeneous. I don't know what the right word is, but like so you want to look at it of like what a cluster group is closer to is like you have like in Kubernetes you have a deployment, and a deployment creates pods, and pretty much all those pods are the same, and the pods are managed by that deployment. And so you don't really take a pod out of a deployment and put it into another deployment. That doesn't really make sense because the identity of it completely changes. So a cluster group is kind of attached to like what's the identity of that cluster, like what identity it should assume. And right now that's largely like what's a set of labels it should assume. So it's really up to you on how to determine that. And it's very easy also to, you can move, it's like you can remove a cluster from a cluster group and then add it into a different group. That might change what's deployed on it, but you can do that fairly straightforward. So it's that one we're trying to, that's sort of like I've kind of struggled with explaining cluster groups, I think, throughout this whole meetup, because it's an important concept, but it's very hard to particularly clearly articulate, and I'm still trying to figure out how to explain it to people, like the importance of it. But I'd say like right now, where it's like every cluster in a cluster group should have some kind of shared identity where you can manage those as a group. So it's like if it's a specific region, or this is all the AWS clusters or whatever. Yeah, so I think we'll figure out kind of like what the best patterns are around managing cluster groups properly as we leverage this more and we get more feedback from people.
All right. Well, with that, I think we're going to wrap up. Darren, Denise, Bill, thanks so much for coming. Thank you, everyone, for taking so much time out of your day. Please feel free to tag us or hit us on Twitter. Darren's on Twitter. I'm on Twitter. We're on Zoom. Zoom. We're on Slack as well. And so please, fire away with all your questions, and please, all be safe. I know it's been kind of a crazy time for everyone around the world, and no different here, but we'll all get through this, I'm sure, soon. So with that, I'm going to wrap it up. Thank you, Darren, again, and we'll talk again in a month. Take care. Bye-bye.
Bye.